Starting today, we're building humanity's first deep space outpost. We will learn how to reliably get to the moon, build habitation, systems and infrastructure that allow us to conduct groundbreaking science. We will take you along with us and inspire the world for generations to come. We have to do this, just as we did with the Apollo program when we first got to the moon. NASA's partners are essential to building the systems we need to live and work in the lunar surface. We're going back to the moon, we're going to stay there, and we invite you to help us build the moon base. Thank you. Good morning, everybody. I'm Carlos Garcia Galan. I'm your moon base guy. Having said that, let's talk about the moon base. President Trump's vision for space exploration requires that we establish the initial elements of a lunar outpost by 2030. What you're looking at today is certainly not the initial elements. It's more of our vision of what it would look like in the future. So when you look at this picture, I'm going to ask you a few times today to transport yourselves to the future and to the lunar surface. When you look at this picture, it's very clear that to execute this vision, we're going to need to achieve the near impossible. But this is what we do. We're NASA. We're going to have to deploy systems in very high cadence that will survive extremes in temperature, illumination, and very complex and rugged terrain with very steep slopes. Everything that we're going to want to do in the moon, unfortunately, is hard to get to. So all of these things we're going to have to do together. And eventually support permanent astronaut habitation there, which is no small feat. We can only do this with a vibrant American industry base and our international partners. And in addition to that, we're going to leverage the entire might of the NASA workforce, from core competencies to facilities to our ingenuity, to make sure that this dream happens. We're going to ensure that American leadership remains in space and on Earth, doing things that today seems like science fiction. It does look like science fiction, but guess what? We're planning to turn that into reality. And with your help, we're going to inspire the world in the process. But this picture of the moon is not going to show up overnight. That's not where we're going to end up. We're going to build it in phases. Phase one, which starts today, it's all about getting to the moon reliably, learning how to get there in high cadence, deploying assets in different areas of the moon where we think we may want to build this moon base. We're going to experiment with new technologies that we know we're going to need for future infrastructure development to support that permanent habitation. And we're going to actually start the infrastructure in this phase that goes from now to 2028. That infrastructure is going to start with constellations of communication satellites that can also do observation. Transitioning to phase two, which we estimate will start around 2029, we're going to think about establishing the infrastructure. So we've tested some new technologies. We're transitioning to actually establishing and laying out what we think are permanent elements of that infrastructure. And we're going to talk about this, but it includes power, surface communication, surface preparation, and mobility. And then once that's established, we're going to transition into achieving semi-permanent and permanent crew presence on the moon base. So that is going to include habitation modules and everything we need to keep the crews alive and enable them to do groundbreaking science and exploration on the surface of the moon. Go to the next chart, please. So the moon has a surface area about the size of the continent in Africa. Imagine, talking about why are we going back to the moon? Imagine sending 6 missions to Africa for short duration and saying, hey, we've explored, we've learned everything we need. We're going to start doing that again. The lunar South Pole, for example, it's about the size of the state of Virginia. So I think you can go one page up. Oh, there you go. We got it. This false color image that you see is the dramatic terrain that's in the lunar South Pole. The Shackleton crater, for example, is one of the areas where we're interested in going. That is double the depth of the Grand Canyon. I don't know if any of you have had the chance to hike the Grand Canyon. I have. So it's quite impressive, and we actually want to explore in the areas of the bottom. We're going to have to build systems that also provide power, mobility, and habitation around those places, and also consider lighting. Like you see today, some of these areas that are very interested for science and exploration are sometimes permanently shadowed or have significant length of shadow periods. So having systems there that can survive the temperature gradients that we're going to see and the lighting are going to be critical. Unlike the lunar equator, the ratio of sunlight can really wildly change. And when the sun comes up, it's not like on Earth or different places on Earth where you see it just straight sunrise or the equator of the moon. It's going to basically hover in the horizon. So power systems and even communication having to go through those craters to work is going to be very challenging. So let's talk a little bit about phase one. Go one more slide. Phase one, these are the top-down objectives to establish the types of things we're going to need in the missions that I'm going to talk about in a minute. We want to achieve high-rate, reliable surface access. Talked about that. Establish the ground truth for the moon-based landing sites. We have a ton of data from satellites, a little bit of data from rovers and other probes and landers we've sent, but there's nothing like going there and experiencing that environment that I was talking about, and prospecting and looking around. So we need to do that in phase one with a high rate of assets. We also need to test and experiment on the technologies that we think we're going to need. They're not a nice to have, they're a must have. We got to make sure that we understand how those are going to work in that environment. And we're going to host the first crewed mission to the South Pole in this phase. So if you're an astronaut, transport yourself back. If you look at the perimeter of the moon base, you're basically going to see, of course, your ride to the moon and back to Earth. You're going to see other landers that were there before you, and then several of other landers and rovers that we were using to achieve that high rate and that prospecting. So this is kind of what it would look like. To achieve that, go to the next slide. We're investing significantly and projecting about 25 launches, 21 landings in that period of time. We're going to put about 4,000 kilograms of payloads on the surface. So the payload capacity is going to drastically change. We're hoping changing the paradigm of what we've been able to do on the moon. We're going to also deploy 2 lunar orbital comm satellite constellations to have reliable comm and observation. And then we're going to do technology demonstrations like radioisotope heating units, which are key to address some of the challenges we were talking about before. If you go to the next slide, these are just imposed on the picture some of the things that we're planning to do. I talked about the constellations that will give you navigation, comm, and observation. We're going to have drones on the moon, and I'm going to talk a little bit more about that later. Well, of course, we'll have the human landing system. We're going to use the Eclipse program that we have today, drastically expanding that to do that high cadence of landers. And then we're going to do a series of different demonstrations. And some of these key missions I'm going to talk about in more detail in a minute. But certainly the radioisotope heating units to survive the night, lunar terrain vehicles, rovers of different kinds, all of those are in our plans. Go to the next slide. I'm going to start talking a little bit about some of the key characteristics of the key assets that we want to put in there. So lunar terrain vehicles. These vehicles are about the size of a golf cart. There's 2 versions of them. One is going to be crewed, and one is going to be uncrewed. The crew version, of course, is going to allow the astronauts on an EVA suit to move around farther distances from their landing site, potentially going from the landing site to the areas where we're going to start setting up some of the elements of the moon base. And the uncrewed version, equally important, is where we're going to be able to do exploration and prospecting. We're going to put payloads on them, maybe some of the technology demos. Imagine perhaps a lunar terrain vehicle with an RHU attached to it, or maybe carrying something related to surface preparation to see what things work and what things don't. Can this thing, push a rock on the moon? Can we level? Those type of things we're going to explore. And here you have some of the key characteristics, 500 kilograms. It can go up pretty steep slopes. 20 degrees doesn't seem like a lot, but if there's any cyclists here, you know that that's pretty impressive. Surviving 150 hours in the shadow and about a speed of about 10 kilometers per hour. Let's talk about the next one, lunar drones. We're calling this Moonfall. So I'm pretty excited about this one. This is built on the legacy of the Ingenuity helicopters on Mars. Obviously, we can't have helicopters on the moon, but we're going to take everything we learned from GNSS systems and the avionics, all of that, to build this. It's going to be used for site surveillance and terrain survey. We want to send this to places that are hard to reach, which is, by the way, points where maybe are the ridges where we see more sunlight, or maybe are places where eventually we may want to put a lunar cellcom tower. So we're going to send them to do the prospecting, and potentially they could host a variety of payloads as well, like an RHU, for example, to further survive the night. Here's a video with some of the characteristics. So the drones themselves are going to be independent from each other. They're independent spacecraft. We'll bring them in and basically deploy them as the spacecraft is coming in. And each drone is going to be capable of basically several propulsive hops that can go about 50 kilometers each in total. And then it's about 150 seconds from launch to landing on each hop. And then eventually we'll place them in a place when we run out of fuel, where maybe they can, if they have something that allows them to survive the night and stay longer periods of time, we can leave them there and have a function, like maybe communications or something like that. Of course, everything we talk about is going to have pretty awesome cameras. The next one is that I want to talk about is communications and observation satellites. Communications is key. We can put all the assets we want, but if we cannot get their data back, or even look at prospecting from the top to see what things are doing, or bring you along for the ride, we're going to get much lower value of that. So building a constellation of satellites, we're very, very used to this on Earth, as you know, GPS, communications anywhere in the world. We got to establish that on the moon as well. So we want to increase the throughput to about more than 500 megabits per second. We want to increase and establish a good amount of surface lengths to orbit lengths, and basically being able to communicate with our assets anytime we want. We're also going to start establishing protocols. So, all the stuff we're going to put on the moon, we want to make sure that it's, standard. And even though the initial set may not have those requirements, we want to test some stuff in phase 1. So maybe by phase 2 or 3, we can deploy those protocols and have a unified comm system on the moon as we develop other capabilities. If you go to the next one, another one I'm excited about, the Viper rover. Viper is also another golf cart-sized rover. It's built, it's tested, it's ready for a ride, and now we're going to give it one. It's going to go in the Blue Origin lander, serial number 2, which is scheduled to go to the lunar South Pole by 2027. What it's used for is going to map the water and volatiles from lunar resource prospecting. And these are critical for some of the reasons why we want to go to the moon. Some of these areas that have permanent or semi-permanent shadows have things that are billions, volatiles that are billions of years old, and we're going to go after those things and to try to understand our universe, where we come from, our neighborhood, to say in a different way. So yeah, this rover is going to get deployed. It's going to help us do a lot of the prospecting and trying to find out where are the cool places to go do science on the moon. Next one, radioisotope demos. I talked a little bit about the lighting conditions on the South Pole, very challenging. So lighting, of course, is related to also the thermal environment that these assets are going to see on the moon. As a matter of fact, at the beginning, during phase 1, some of the things we put there are not going to last very long because of this very reason. So anything we can do to not rely necessarily on solar power and allow the assets to get heating and maybe some power is going to be golden for our ability to take that forward. So we're actually trying to incentivize any of the people that have landers. If you can find an RHU or anything related to that works for your asset, bring it on, and we're going to reward you for that. As a matter of fact, also, we're thinking of several things along this area, but I'm going to talk about this later too. We're going to put an RFI today, dropping it, for any ideas that you may have. We want to hear them. So anything in this related to this technology area is going to be good. Basically, we want to put things that will help the lander survive more than 120 hours of continuous operations in darkness and be able to send signals back to Earth. Let's see. Let's go to the next chart. So all in all, this is phase one for you. It's very challenging timeline that we completely understand that, but as I show you in the first picture, we need to achieve the near impossible, so we cannot operate the way we've been talking and operating until now. We're committing about a $10 billion investment in these years through 2028. In 2026, we already have 2 missions planned to the South Pole using our CLIPS program that we're folding into the moon base. 2027, we're drastically increasing that mission cadence with 10 launches to put 9 landers. And all of this we're going to do depending on what we get from solicitations, the stuff we have on the books today. So these numbers are obviously approximate. In 2028, we want to maintain that cadence and potentially do 12 launches to put 10 landers on the surface, including the HLS provided landers for demos and of course to bring the crew for the first time. Go to the next chart. Okay, let's talk about phase 2. So, all right, we've learned how to get to the moon reliably. We've tested technologies. Now we're transitioning into, we're building the moon base. So we're laying out infrastructure to be able to support the habitation modules later. We're going to drastically increase the CLIPS lander payload mass capacity to about 5 metric tons. We're going to use some of also the heavy cargo landers, so there's a lot more than that coming. But from CLIPS perspective, we're wanting to increase the size of the landers and their ability to take cargo. We're going to do technology demos to enable lunar permanence, and we're going to, at this point, we would like to increase our crew visits to the moon base, doing it semi-annually, so 2 missions per year. Top objectives. All right, back to the moon. Think about if you were an astronaut, what would you look at if you're looking at the moon base? So you saw some of the rovers that you saw in phase 1. Maybe some of them are not working anymore, but they're still there. You see additional rovers with increased capability. Definitely you see lunar terrain vehicles that have been hard at work, maybe preparing the surface for a potential habitation module or multiple modules we're going to connect. You see some of the infrastructure that's coming about, like solar tower masts and so forth. So if you go to the next chart, that's about what it looks like. 27 launches, 24 landings, 7 rovers, and drastically increasing the payload capacity that we want to put on the lunar surface. By this time, we would like to also have, you see, a pressurized rover that we're doing with our partners at JAXA. You see solar power stations. Definitely, we're building up on this nuclear capability, maybe graduated from RHUs to RTGs, maybe something else, if we get good ideas from you guys. So we'll start setting up this kind of infrastructure. And some of the assets, if you go to the next chart, in addition to what we did in phase 1, we definitely have solar power augmentation. So you start seeing some of those solar masts growing. We'll have RTGs, maybe on a rover, maybe on a lander, maybe some things that we can connect together. We start seeing some of the infrastructure like surface communications, our cell towers, which also give us the ability to do navigation. Pressurized rovers, of course, excavator rovers. So we need to, connecting things on the surface of the moon is going to be almost harder than on orbit because you got to deal with the terrain. So we're going to work on the technology for that, but also having an even surface, even if it's just clearing up rocks, is going to be key. Site preparation logistics rovers, logistics, if you want to have a vibrant moon base, you have to have a logistics train. From launches to in-space transportation to landers, and then getting that cargo from the landing site to where it needs to go. So using perhaps LTVs or an extension of other rovers, we're going to have to experiment and start setting that up from when crews are coming there. All right, so transition to, let's talk about the assets that we're going to have there. Of course, one of the great ones is the pressurized rover that, again, we're doing with our partners in Japan. It's a mobile habitat that is going to extend the human exploration range. They'll be able to work in a short sleeve environment, so it's kind of a habitation on wheels. And that will allow them to travel significant amount of distance. Of course, it will have power systems and so forth. We're designing this to have a 10-year design life, and it's about 15 metric tons. So, of course, to deliver that pressurized rover, we're going to have a heavy cargo lander already in the books. Can traverse quite a few degrees of slope, and then survive up to 150 hours in the shade. The whopping speed is 3.5 kilometers per hour. But trust me, if you're in that, you probably don't want to go any faster. So anyway, pressurized rover. Transition to solar power augmentation. Power is the name of the game. All of these things we're showing require power. Some of them require power to heat themselves during the long shadow periods. So we need to demonstrate the ability to deploy these systems, test them, and then chain them together eventually to be able to provide the power that we need for the moon base. So anyway, we're definitely going to be investing in this capability, deploying it, testing it. We're looking, when we deploy some of those permanent assets, we're looking at about 10 kilowatts plus during illumination. And then when we're in the shade, 360 kilowatt hours for the assets that we want to serve. You're thinking, okay, we have habitation modules, so it's for that, but we also have a bunch of rovers. So maybe having stations where the rovers come in, hook up to it, either with, cables and connectors or wirelessly, and charge up is some of the things we're going to have to do. All right, next. In the theme of infrastructure, which is really the theme of phase 2, surface communication. So we want to establish and expand the network to enable more throughput, more connections, constant communication with our surface assets. We want to deploy dedicated surface-to-orbital communication stations, and you see a little bit of a picture of that in the landscape, and deploy the system for direct communication across the surface. And again, I talked about earlier with craters all over the place, which is where we want to be. It is going to be hard to achieve. There's a lot of multipathing. There's hard to find line of sight places to communicate directly. So all of that, even though we all know communications, doing it on the surface of the moon in the South Pole is not going to be easy. We're looking at perhaps 10-kilometer range of direct line of sight. That's what we want to achieve. All right, and then one of my favorites, the site preparation and logistics rovers. We're already starting. I'm going to show you a video of that later. We're starting to experiment with this on the ground. So these are rovers that are deployed to start working on surface prep. And we want them to last long so they can be working for us while the crews are preparing to launch to come to the lunar base. We're thinking this is a key capability for the lunar terrain vehicles, the upscale version 2 that we want to be deploying during phase 2. And also, we may want to be doing some excavation and compaction. I know this is very challenging in 1/6 gravity. We know that. We're testing, like what you see here, and you'll see in the video, is like double drum to even that stuff out. But there's many challenges that I'm sure you can come up and have maybe good ideas that we want to hear about. We're going to be investing in this capability as well. And then, if you go to the next chart, nuclear surface power capability. So we talked about experimenting a lot. Maybe the beginning in phase 1 is really just to heat yourself while you're in the long lunar night. But now we're going to want to be working on these things to supply power to multiple assets so they can survive the night, and eventually also provide power for operations. So we're talking about hundreds of watts, demonstrate technology, process, and operations at a larger scale, connected together, thermal management concepts for larger applications, anything related to systems that can give us a significant amount of power. So anyway, if you're working on that stuff, you'll be excited to hear that today. All right, so if you rack and stack phase 2, which goes from 29 through 32. 29, we're planning approximately 6 launches, 5 landings, 2 rovers. The cadence, the number looks smaller, but all of these systems are heavier. So we're more in the medium to large class of landers at this point. So the delivery of mass is greater, but the numbers are a little bit less. So 29, 6 launches, 5 landings, 2 rovers, 2 surface infrastructure elements. 30, 7 launches, 6 landings, 2 rovers, 4 moon-based drones with upgraded capabilities. 31, 7 launches, 7 landings, 2 rovers, 3 surface infrastructure elements. And in 32, 7 launches, 6 landings, 1 rover, and more drones. This may not be exact, but these are the numbers we're working for. And we want to show you the signal that this is the type of cadence we think we're going to need to develop this moon base in the time frames that we want. So we're going to talk about challenges, and clearly it's perhaps out of our experience base, but that's where we need to get together, come up with the things, identify things that are slowing us down, preventing this type of cadence, working on that together, addressing it head on, and putting it in play. All right, phase 3. So top level objectives: long duration and long distance human exploration. We want to increase the CLIPS lander payload mass capacity to 8 metric tons. We want to do a bunch of regolith manipulation and site preparation capable rovers. We want to start the routine logistic flights to deliver to Earth. And then we'll do initial uncrewed mission cargo returns, maybe up to 500 kilograms. So we start having a serious both ways train of logistics. Back to the moon. Just take a moment to really picture yourself in an astronaut suit, looking around and imagining what you would see there. Definitely see a bunch of infrastructure for power, both potentially nuclear, which is maybe shielded, to a bunch of solar array towers that are either directly connected to the habitation modules or perhaps on the side at different locations, providing power to some of the assets that are moving around. Pressurized rovers, advanced LTVs, and then different landing sites for human landings, cargo landings, and potentially launching cargo vehicles back to Earth with a bunch of moon regolith. This is kind of the stats. At this point, we're talking about 150,000 kilograms of payload on the surface when you account for all these things that we're talking about. One more chart. So again, some of the highlights that I've been talking about. Habitats, that's the highlight of the moon base in its end state, and what we're going to be focusing on phase 3. Logistics, can't talk enough about logistics and the need for that to do it reliably. We've learned anything we've done long duration, whether it's on Earth, low Earth orbit, we know we need logistics. So I mean, everything that has anything related to that. In situ manufacturing or resource utilization, we're going to start seeing some sites on the moon that are kind of like the industrial neighborhood, where we're trying some of that technology and also using it to actually keep the moon base growing and viable. We'll have different locations for habitats, and then widespread power distribution, and then we'll see an increase on communications as well, surface, and potentially we have additional constellations at this point. Okay, so the focus areas for phase 3, talked about logistics. I won't impress that upon you anymore, but we're thinking about 8,000 kilograms of carriers, consumables, and other items. Some of the challenging stuff is going to be to go get the stuff from where it is and put it where it needs to be. So when the crews come, it's there for them. And what we know from doing permanent habitation in low Earth orbit, for the crews, that you need clothes, of course you need water, you need air. There's a lot of mass for even short duration missions. Like a month, staying there for a month requires a significant logistics and supply capability. So If you go to the next chart, we'll talk about habitats, star of the show in this phase. So we want to enable continuous human presence there. We potentially are looking at multiple locations. We would like to expand into different modules that are connected together, but we'll evaluate if that's the best play. We definitely want to expand our capabilities in ECLS, surface mating, and of course, airlocks. We are, we're going to be experimenting with this, and of course, the pressurized rover and the things we have already done with ISS, all touch on these things, but it's going to be the next layer of complexity when we try to go to the moon. The basics, air, water, food, space, all of those things, a few nights in space, in the size of a minivan, it's manageable, but when we expand to short trips, those needs get much bigger. Let's see, I think I'm going to move to the next chart. Cargo return. So initial demo we'll do in phase 2, but here we want to use it at full scale. So at phase 3, we want to definitely increment and implement a capability of a mass goal of 500 kilograms sustainably. So here we'll put our science returns, critical hardware, and anything we can do to inspire the world will have a place in our cargo return missions. All right, and then the last one, I talked about this a little bit earlier, but in situ resource utilization and manufacturing as well. 3D printing with regolith on the surface of the moon, it's something that we should be striving to do. So we'll experiment a bunch, and then we can hopefully put this into play for phase 3. This is something, when we talk about moon to Mars, clearly when we get to Mars, we're gonna need some of this capability, and when you get there, it's going to be tried and true and something you can rely and count on. So that's what we're going to be learning on the moon, how to achieve that. Key commodities that we may extract from regolith, of course, oxygen, water in general, rare earth elements, hydrogen, all of those things we're going to experiment with. Next chart. So here's the timeline for missions in phase 3. So another about $10 billion investment in this phase. We're currently planning for a capability to include 3 new habitats, including the multipurpose hub that we're already planning, 3 more rovers, 2 more surface comm nodes. By 2033, for example, we expecting to add 2 rovers and our first habitat and supporting logistics capabilities, 6 landers, over 7 launches. 2034, we'll add our next habitat and supporting logistics, more surface communications. 2035, 1 more rover, perhaps another habitat, supporting logistics, and a bunch of launches and landings. And then in 2036, potentially more habitation volume and all the things that come with that. In total, when you rack and stack the 3 phases, this is what you end up with. So it's pretty impressive, equally challenging. Remember, trying to achieve the near impossible here. And this is what's going to take to accomplish this goal. So I'm not going to rack and stack these numbers for you, but you have it there. You're going to start getting your brain around it. All right, so the next chart. We talked about some of the things that we want to experiment on the moon. Of course, we can also do that on Earth. We've already started. So here's some videos of folks, NASA folks, and also some of our industry partners working in some of this technology, from rovers that can go up terrain, fuel transfer, regolith preparation, manufacturing, and all kinds of things, avionics, hardening. All of these things we're already investing in, and some of these things, surface mating and docking, some of these things are ready to go to get, they're just waiting for a ride and a lander to get to the lunar surface and basically showcase what they can do, and that's what we're going to start with. Okay, so here's all the cool aspects of putting assets on the surface of the moon and traversing and potentially experimenting with what we're planning to do in the 3 phases. I could watch these videos all day. All right. So one of the key things, you go to the next chart, one of the key objectives that we have is not only to develop the technology that we need to eventually go to Mars, establish a moon base, which we have never done in deep space. It is imperative that we inspire the next generation of engineers, communicators, explorers. We can only do that if we take you along with us. We're going to basically require that every asset that we have has a bunch of cool cameras, things that will give us the perspective of what we're doing, which to date is almost like science fiction, and things that will inspire people that are currently in college, high school, middle school. It's like, wow, that is what I want to do. That's what I want to dedicate my career and my life to do. And they will be the ones that come up with some of these challenging things that we don't know how to solve yet. So we're going to have a website that we're starting already working on, where you will be able to follow us along the way, from launches to things getting to the moon, to the rovers prospecting, getting to places that we have never seen. We're going to enable that capability with constellations of satellites that are looking down at the moon base and checking out what things are doing. We're going to follow the drones, the moonfall drones around the moon, to see where they can get to and what they discover. And all of that, you'll be able to do it along with us and hopefully eventually work with us in some of this cool stuff. We talked, go to the next chart. We talked a little bit about, when I show you that phase 1, 2, 3 collated set of missions and all that stuff, it's a huge challenge, and we know that. To achieve the near impossible, we are driving to high volume of complex missions with challenging execution timelines. We know we're going to stress the supply chain. Maybe as of today, supply chain is not ready for this. We're going to basically need to access reliable facilities that allow us to do the very unique testing that we have to do for surface operations. Manufacturing capacity and capability, technology maturation. All of those things we understand. That's why we dropped the RFI today, to get your ideas on what can we do better, what's slowing you down, what are things that could turn your capability to enable us to turn science fiction into reality. What are those things? Bring it to us. In addition to that, and you heard Administrator Isaacman talk about that earlier, we're going to use the NASA workforce in a way that perhaps we haven't in the past, especially recently. We're going to make sure that these missions are as reliable as we can make them. We don't want to impede the innovation from industry, but the things that we know how to do, we're going to embed. So we're going to really focus our NASA workforce to basically helping you in industry, providing solutions. If you want them to work in line, they will be working in line, and then also reviewing the things that you're doing to make sure that we have a good shot. We're going to take a lot of shots on goal. We want to win a lot of games as well. So we're going to put that into play, as well as we're going to do a review of our facilities. Some of them have unique capabilities that nobody else has, and we want to make those available for you so we can do this together. So again, we need your ideas. Drop them in the RFI. Okay, so we've talked a lot about what are we doing. Now we're going to talk a little bit about how we're doing it. So we basically structure this in different functional areas: transportation, launch, and also orbital transfer vehicles for whenever we need those, perhaps for logistics; surface mobility, transportation for landers; infrastructure, logistics, and habitation. So I'm going to touch on some of these things. If you go to the next chart, realize that we've actually been working a lot of this stuff for a while. Today, there's teams, projects, programs that are working on all of these things individually. What we want to do, and this chart is not to project a future org or anything like that, the point we want to make here is that every asset, every kilogram, all the lunar exploration resources that we have are going to be focused on one thing, and that is to build the moon base. We're going to partner with our science teams to really think about what are the capabilities we need, what are we deploying, what's the science that should go with it, and put it all together. If you go to the next chart, I'm going to basically step through some of these things. For launch and transportation, we're planning, you saw the launch cadence, which is pretty significant. Moonbase will leverage Kennedy Space Center's launch service program and the deep space logistics projects to their expertise to manage, sustain commercial lunar delivery services. Building from our reliable surface assets with access, which we're going to set up and starts in phase 1, we will manage a commercial mixed fleet strategy that enables diverse, flexible mission support, standardized delivery interfaces. We're also thinking that we're going to help with, perhaps helping with, get the landers, get the infrastructure, and maybe have basically a conveyor belt of landers, payloads, ready to launch, put them in the rocket type of thing. Moving forward, of course, landers, key thing. Here's a picture of some of the things that we have been projecting through CLIPS and HLS, things we have today, low mass, medium class, and heavy class landers. If you go to the next chart, the CLIPS program is one of the tools we're going to leverage pretty heavily. So originally, CLIPS was set up to enable low cost, more risk tolerant, lunar payload delivery opportunities, basically to incubate new US-led industry base to work on landers and capabilities to deploy them. What we want to do requires a lot more than that, so we're drastically expanding the CLIPS program. So the lander payload delivery capability is going to now go through phase 3, potentially beyond. We want to increase mission reliability, and that starts now. We're putting things in the contract updates that we're doing to allow you to leverage the NASA expertise for both inline work and also, us looking over things that you're doing and areas where we can help. Also to increase the mission quantity and cadence. To achieve this goal, I'm gonna have some procurement charts also coming up, and we're gonna talk about extensively tomorrow. But we're gonna release 2 new requests for a proposal for task orders to support phase 1. So it's taking what we have today with the current providers and expanding that. And then we're going to structure a way in which you can leverage on the NASA workforce more than you could before. And then we're going to release a follow-on CLIP solicitation to support phase 2 and 3, where we're going to open up again and expand the pool of providers potentially that can bid on those things. So definitely a WASIS for CLIPS. And hopefully you'll get to read the solicitations and the stuff we're putting out today and be excited to participate in this building the moon base with us. All right, large cargo landers, not going to talk about much of this because this is already in play with the HLS program. So quite a bit of capability that it's in process of being available for, especially for phase 3, for phase 2 and 3 for us. Go to the next chart. Transportation elements. So we talked about the land services. We'll have new lander opportunities with the solicitations that we already talked about. And some of the CLIPS deliveries are kind of summarized here. And again, we'll focus on the details all of this tomorrow with open sessions and also closed sessions with existing providers. Next chart. Okay, infrastructure. So here's where we're going to talk about communications and also power. So I'm going to step through this. And in these charts, I'm going to talk a little bit about the evolution that we are looking for. So when we talk about communications, here's the different things we're going to have wholesale at the different phases. So phase 1, we talked about the constellation of comm with observation, and as a bonus, if we can get navigation, we'll strive for that. Then phase 2, you get to the definite navigation on the on-orbit constellations in addition to surface communication, and potentially we'll also entertain the possibility of doing an atomic clock demo. So eventually we can build a very reliable navigation system on the surface. So the evolution, if you go to the next chart, please. The evolution of this in phase 1, and I've talked through some of that, some of these capabilities already, but I wanted to kind of put it in a summary. So orbital comm, PNT, relay, deploy. We're going to deploy our initial 5 satellite constellation that's already in progress, and we're going to look to add a second constellation that's dissimilar to that. One of the things we want to do is get in there and put significant observation capabilities and start playing around with protocols that we can then count on in the future. Phase 2, we go to the surface for permanent surface cell towers, and then simultaneous support and comm from different assets. And then this is where we start building the navigation infrastructure. Phase 3, is the surface communications, expanded capability with standard protocols, and the same thing for navigation. Next chart is gonna dive into the surface power. So click one more, and of course we'll start with solar and regenerative fuel cell type of technologies. We will go into the RHU for heating some of our assets and RTG in phase 2. Definitely experiment in phase 1 as much as we can. This is a key infrastructure component. And then in phase 2 is when we're gonna actually start deploying and linking things together. And then the fission surface power program, it's scheduled to deliver something on phase 3 for more capacity and maybe more than one thing, for the capacity that we'll need for the moon base. Next chart. Here's kind of the phase evolution of that. So deploying the assets for communications, that's an infrastructure thing we're going to do in phase 1. Demo, nuclear and other things that will allow us to do the survive the night and long shadow periods. Then we transition into the deployment of the power infrastructure on phase 2. Solar and nuclear, and then, completing that and distributing that to all the assets during phase 3. All right, mobility. There you go, one more chart. There you go. So this is the combination of all the mobility assets that we plan to have. So in phase 1, definitely a bunch of rovers of smaller size with different payloads and capabilities for prospecting and experimenting. We'll also have the lunar terrain vehicle. I'm going to talk a little bit about that in a minute, but we're going to change a little bit course on that, and basically we'll have incremental capability build up for the LTVs. So LTVs in phase 1, more capable LTVs in phase 2, and even better on phase 3. We're definitely looking for our international partners to also help in this area. This is a great opportunity. We're going to have definitely transportation capability by this point in phase 2. So looking for what are your ideas and capabilities that you want to deploy. And again, rovers, from having prospecting to surface prep to carrying logistics around, something we're going to need. Science rovers, of course, that's why we're going to the moon for. To do the groundbreaking science, and then of course pressurized and advanced LTVs in later phases. Go to the next chart. Here's the evolution of that. During CLIPS 1.0, we already talked about delivering several rovers, including Viper, Flip, and the Rashid UAE rover. We were bringing in the drones, Moonfall. So those things I already talked about, what they would be used for. And then the LTV phase 1 capability, we'll talk about this a little bit more in a minute. Phase 2, more capable LTVs with increased reliability, service life, survive the night, payload capacity. Partner rovers, of course, including the pressurized rover, that's a big one in this phase. And then science of all kinds, and of course landers. And then phase 3, we are in an operating mode with permanent habitation there, so certainly anything you need in a moon base, crewed and uncrewed, of course, more surface preparation, a lot of things that can do logistics movement. And all along the way, partner rovers, we're open for business there. All right, for the LTV, I want to talk a little bit about the pivot that we're doing here. So the original contract was really set up to deliver a fully capable crewed rover to survive 10 years. So pretty hefty requirements. In our current schedule and the challenges to get to that state, we were projecting a delivery to the lunar surface by 2030. As you can see, we've shifted in our objectives because we want to start right now and we need stuff in phase 1. So this approach really put us in a significant cost to deliver the one asset later on. A lot of technical complexity to I have to address immediately instead of build up incrementally. And schedule put us in a kind of a no-fail solution space. If the rover was late or if it didn't pan out, didn't have the capabilities, by 2030, we're going to need that capability pretty significant. So we're pivoting. Okay, so anyway, what we're going to do is to enable basically gaining quicker access to crewed and uncrewed, we're going to change the procurement strategy for that and basically talk to our partners that were already on board and talk about deploying, doing solicitations for much earlier, perhaps less capable rovers, and then incrementally build that. So we're changing the current contract today, and then we're going to put solicitations for phase 2 of that, and then eventually we absolutely predict the demand of that, where we have to deliver an LTV, every certain months for the duration of the moon base. So pretty exciting evolution where we're going to need a lot more capability, just a little bit of a change from where we are today. And this is what it looks like from a procurement strategy perspective. I'm not going to read that to you. And again, we'll have sessions on this tomorrow. Next chart. Okay, habitation and logistics. So you go to the next chart. In the picture of the moon base, this is what we're planning. Phase 1 is when we'll start really working on the technology development and trying out things for logistics deliveries. Phase 2, of course, we will have pressurized rover as a habitation kind of a demo and trial. And then phase 3 is where we get the habitats and then the cargo return. And here's the evolution of that. So phase 2 started deploying the logistics capabilities from 500 kilograms to 1.5 metric tons, demoing some of the things related to the logistics train, demo habitation with early capability and the press rovers, and then the build-up of that in phase 3. All in all, if you go to the next chart, in the next few months, this is what the procurement opportunities look like. From CLIPS 1.0, expanding that for science payloads as well. Starting CLIPS 2.0, it's coming up. We'll be awarding that in this year, in the summer. Rephasing LTV procurement the way we had designed it. And then the moon-based capabilities, RFI, which we really hope you take a look at and give us your ideas, because you can see the next several years is going to be insane from the perspective of the amount of capability potentially we'll be able to put on the moon. So I hope that sends the signal to you that we want to work with you, we need you, we got to do this together. And we're starting with a significant investment to make that happen. And then, before I close out, I just want to reflect on the picture you're seeing and what that may mean. So, starting today, we're building humanity's first deep space outpost. We will learn how to reliably get to the moon, build habitation, systems and infrastructure that allow us to conduct groundbreaking science. We will take you along with us and inspire the world for generations to come. We have to do this, just as we did with the Apollo program when we first got to the moon. NASA's partners are essential to building the systems we need to live and work in the lunar surface. We're going back to the moon, we're going to stay there, and we invite you to help us build the moon base. Thank you.